Okay, now I'm really glad to welcome Ansgar Delahaye, a project engineer at TÜV Rheinland. He has been associated with TÜV Rheinland for many years. He also worked in PV production facility design and has supported companies worldwide in setting up or expanding PV module production facilities, including Bosch, Alio, Solibro, and Qcells. Ansgar will provide an overview on bifacial modules and system performance. Ansgar, the floor is yours. Ansgar. Min?
Yeah, this was the right button. I'm sorry, I was looking for the right button. Let me just quickly start my my slides.
Sure.
So everything perfect like this? Is that okay?
We are not seeing your slides yet. So maybe you have to do the screen sharing and then
my video should be starting now. Yes. And my slides. Can you see my screen already? No.
Not yet.
So where's the button?
You have to share screen. There is a green button.
Yeah, I found it. Okay. Now you should be able to see it, right?
Perfect.
Okay. So thank you, Shravan, for the moderation, and thank you, Olga, for this very good introduction and overview for bifaciality. Thank you, Michael, for the invitation for the speech. And yeah, first of all, I should say hello and good afternoon to all people being in the conference, in this interesting conference. My name is Ansgar Delahaye. Let me shortly, how can I switch? Now it's working. Shortly introduce our company. We are visible since 40 years now in that field of photovoltaic, offering services as power plant inspection since 1990. We do have more than 500 locations in almost 60 countries worldwide, providing 8,000 meters square of lab testing areas and 250 plus people, experts working worldwide in this field. My name is Ansgar Delahaye. I'm working in photovoltaics since 15 years now. My first step actually was at TÜV Rheinland at the type approval of module types. Then I switched 10 years to a consultant company you mentioned already, Shravan. Consulting companies that were starting up their module production lines. I came back to TÜV Rheinland in 2017, and my expertise focused on energy yield analysis, on project management for different international projects and R&D topics. My speech will cover the introduction, which already happened. Of course, for TUV, I will focus on test standards and certification being related to bifacial modules. We will look at energy weighting procedures for bifacial PV modules as we approach them at TÜV Rheinland. And finally, I will close up with some results of our outdoor exposure measurements. So if you look at the world of standards related to modules, to photovoltaics, here are the most applicable ones. We do have the ISC technical specification that determines the way how to measure exactly the output power of modules, and also for in the version -2 it also covers bifacial modules. Luckily, we have that specification already quite early in when bifaciality came up. Then, if you look at product qualification processes, we have the ISC 61215 for quality measures and design. That has been recently renewed and published end of last month. There's still things to be applicable related to bifaciality in the ISC 61730 safety standard. That's still in work, and I assume that should be released in about 1 year's time. There are no changes proposed for PV materials and components related standards. There are changes that are necessary for energy rating. I will talk about that later. Beginning with the actual procedure, how to measure the performance, the power output of PV modules being bifacial is, as I said, defined, specified in the technical specification 60104-1-2 that has been mentioned already by Olga. This technical specification is existing since a year already, since 2 years already, and after 3 years it will become an international standard after a review. The objectives of this standard, this technical specification, is to determine the bifacialities and the output power of the modules with variable rear side irradiance. This can either happen in solar simulating applications or at natural sunlight. If it comes to solar simulator, we do have the opportunities to use single-sided or double-sided illumination, while under natural sunlight, we do need to apply 2 additional PV measurement devices to cover also the rear irradiance that is hitting the module from the rear side. So the actual, the requirements for the module solar simulators are, if it comes to one-sided illumination, that we need higher irradiance levels as we normally do. We normally go for 1000 watt per meter square, which is defined as standard test conditions. But now, if we want to reflect also the irradiation coming from the rear side, we have to at least add additional irradiance from the front side, which is typically up to 1200 watt per meter square. At the same time, we have to shade the rear side, and the standard talks about less than 3 watt per meter square that at any point might hit the back side of the module. Uniformity is defined to be better than 5%, so that's class B. And a formula to calculate what we call equivalent irradiance on the front side is that what we usually have on the front side, the 1000 watt per meter square, added to the product of the bifaciality factor and the desired irradiance or the reflected irradiance for the rear side. I will come to that detail later again. If we have a double side illumination, it's easy. From the front side, it's only 1000 watt per meter square. And from the rear side, you do need a variable irradiance, which typically varies between 100 and 300 watt per meter square. So the approach, if you want to determine the power output of a module with a single phase solar simulator, is that you, in the first step, do the normal STC measurement from the, so you illuminate the module from the front side with 1000 watt per meter square. Backside is kept dark. And you can determine the values for ISC, VOC, and Pmax for the front side. Then in the second step, you turn the module, you do exactly the same, but illuminate only the rear side, again, gaining the values for ISC, VOC, and Pmax, this time for the rear side. Now, if you build the three relations for the values you determine from the rear side and the one for the front side, you do get the three bifaciality factors. And to come down to just one bifaciality factor, it's defined in the technical specification that we then use the minimum of the phi for ISC and the bifaciality factor for Pmax. Just going through this determination, you would neglect all internal losses of a module which come from a higher current going through the module if it's applied in an outdoor situation, having also an additional gain from the rear side. And to cover that, an additional bifacial factor is determined, and that is the so-called B-phi factor, the bifacial power gain. Here we start from the standard, the STC measurement on the front side at 1000 watt per meter square, and add another 100 or 200 watt on the rear side to simulate the irradiation on the rear side. But as said, we are working just with the front side simulator, so we have to add this to the 1000 watt per meter square. The output power you gain during these measurements can be shown in a diagram, and if you then combine them in a linear fit curve, the slope of that curve gives you the bifaciality factor, the B-phi factor. Having this B-phi factor, you then can calculate the estimated output power of your module with variable rear side illuminations, for example, for solar simulation. So as said before, also these bifaciality effects have an income, or had to have an input into the standard, the ISC 61215, and that was released recently. But in the first stage, it was a bit confusing for whole industry when it came to how to document the power output of bifacial modules. So all module producer putting their feet into that topic very early, they just made their own approach how to document the power output. For example, just remarking on the label that the power output contains the front and the rear output power. Finally, give a more clear definition and telling the customer that all the values given above are measured at irradiation of in this part of 1200 watt per meter square. So it was clear, and it needed a further standardization in this point. So what TÜV did in that stage, we evaluated scientific researches. What is a typical reflectance, the typical irradiance one would expect from the rear side to come to a standardized illumination from the rear side. And that led into what we call 2PFG, that's an internal standard of TÜV Rheinland. We take benefit from before official standards are released. And in this case, we defined 1000 watt per meter square for the front irradiation, 135 watt per meter square for the rear irradiation. And if you have to deal with a single site simulator, then an equivalent irradiance of 1000 watt plus a product of bifaciality and 135 watt per meter square for the rear side should be reflected. Exactly this approach and this formula to estimate the irradiance during the test and also covering the values on a label, they found their input in the recently released or published ISC standard 612-615. And here the exact same calculation, which we call BSTC, the bifacial standard test conditions, were named the BNPI, the bifacial nameplate irradiance. So this could be a typical nameplate or data. Also, the same values should find their way into a data sheet of the module. So on top of, in addition of the standard test condition values for PMPP, the open circuit voltage and the short circuit current, you will find the same values for the irradiance at BNPI, so the additional 135 watt per meter square on the rear side, and also the bifaciality coefficients for the three conditions, working conditions of the module will be found on future labels related to the new standard. In addition, we have to reflect the typically higher current in bifacial modules when it comes to other tests we do in according to the type approval testing procedures in the 612-15. So we always have to reflect a higher rear irradiation leading into a higher current through the module. So also here we had in a very early stage a 2PFG that was defining the additional testing requirements of bifacial photovoltaic modules. And also these approaches we defined very soon or very early have found their way vastly into the new established standard. In that standard, there is the definition of a so-called BSI, the bifacial stress irradiance, and that is only 300 watt per meter square to be reflected for the rear side. And this will be applied or will be leading into a higher current that will be applied to the module during the different tests the modules have to run through. This is applicable for the temperature test, the thermal cycling test, where power is or current is given into the modules during the climatic test. The hotspot endurance test has to be done with a higher current, the bypass diode test, and also the reversed current load test. So on the middle column, you find the definitions that have been applicable in the old 612-15 standard. And on the right-hand side, you find the higher current definition that has to be applied in the new standard. Another test that has found its way into the new 612-15 standard is the module qualification test number 21, the PID test. And also this test has a special sequence how to deal with bifacial modules. It includes an irradiation process for the rear side for the stabilization after the thermal stressing of bifacial modules. But what we found is that the test methods described here in both in the 61215 series and also in the 62804, they do not reflect the different degradation mechanisms of different cell technologies. And for that reason, we see there is the necessity of a new definition of different processes, different testing processes and rating criteria to reflect these different cell technologies. We are working on that, and our expert in this topic is my colleague, Mr. Theodoros Makris, and he's very open. If any question comes to this, please refer to him. Energy rating of bifacial modules is described in ISC 61853 series. And also here, of course, we have to find a specified way how to measure bifacial modules. This is still under discussion, and we delivered or developed an approach here. The approach covers a combination of an indoor test program where we do, of course, the output power characterization, as I have explained already before. We do measure the temperature coefficients and the low irradiance in a matrix. We measure the spectral response and the angular response in indoor test processes. In the outdoor test program, we supervise the stability of the module and the outdoor performance. And from the measurements we gain here, we can calculate the operational efficiency, the specific yield, and the module performance ratio, which is the most focused parameter here in total. From the indoor test measurements results, we can calculate what we call the linear performance loss analysis. This is an additional set of parameters related to the module, which easily allow, without a simulation program, to estimate the performance, the yield performance of the module in different climates. So the combination of this additional set of parameters in combination with climatic data in a special format allows to see or to estimate that energy yield in different climates of the world. If a client runs through that process, and we also offer to publish a certified energy yield rating that shows the efficiency of that specific module in relation to others. The measurement places we offer is to cover the different climates is Chennai to cover tropical climate, Tuval, which is coastal desert, Cologne for moderate climate, and another test field is in Tempe, USA, and covers dry desert climate. In all places, we have identical measurement equipment measuring the MPP all 30 seconds. We trace the IV curve all 10 minutes. The temperature of the module is measured all 30 seconds, and the in-plane irradiance, as well as the rear irradiance, is measured every minute. In addition, we have meteorological data, of course, as temperature, wind speed, humidity, and so on. A first result of our measurements in these different places with monofacial and first bifacial module types revealed, of course, there is a high gain from bifacial, gain difference from bifacial to standard modules, to monofacial modules. And as well, what we discovered was fluctuation of bifacial module types, which could go up to 4 or 5%, which you can see here in the yellow bars, for example. If it comes to further analysis of outdoor exposure measurements, I would like to point on a new study, a new paper that will be issued very soon from the International Energy Agency. In the task 13, they are focusing on renewable energies, and this time the performance, operation, and reliability of photovoltaic system focused especially on bifacial photovoltaic modules. The input from our side was also based on the measurements we've gained in these different places I explained. And first key findings here I would like to present are, for example, a very different additional gain you get for different for bifacial modules in comparison to monofacial. For example, in USA it was 8%, while in other countries like Germany we already gained almost 12%. Similar in Saudi Arabia, and in India also we had a gain of 22.4% in addition, if it comes for module performance ratio, not efficiency. So our key findings from all these results were that we find a clear advantage of bifacial modules in terms of yield performance. So our module performance ratio gains were even higher than 20%, partially. Bifacially highly depends on the cell technology, that is varying from 60 to 90%. Very surprisingly, the bifacially coefficients may vary from ±2% to ±5% in production of modules for this of the same family. And once modules are under real condition, the bifaciality coefficients plays a minor role if it comes to bifacial gain. Even differences between PV module types of 15% result in a module performance ratio change of less than 2. So at the end of my speech, I would like to point on these additional informations we offer if it comes to standardization processes for floating solar. And also we do have a webinar of our results of aerial inspections of PV power plants I would like to interest you for. Thank you very much. So
okay,
I'm open for questions.
Yeah, thank you very much. I really learned a lot. So even you clarified a lot of questions which I had earlier, and it's also very interesting to see that you know the module performance ratio doesn't really matter so much despite different bifacialities. I think this is really interesting findings. Actually, there are several questions. Probably we don't have time to really go through everything. But you know, there is one question I would like to take, like on slide 8, you mentioned that you know, this question is regarding on slide 8, how to address the low light response while calculating the rear side power at 100 to 300 watts per meter square.
I'm sorry. Let me look at slide number 8. That's clearing the question, maybe. So yeah, the question was how we determine the power output.
You know, how to address the low light response. You know, when calculating the rear side power at you know, you were suggesting to take a different rate power, right? So how we can account the low light response between 100 to 300 watts per meter square?
It's not reflected within this measurement, of course, because here you irradiate the module from the front side with much higher irradiations than 1000 watt per meter square. So it's not reflecting the low irradiance efficiency of that specific module. If that is the question, the answer is it is not reflected within that specified measurement procedure. If you want to learn about the low irradiance efficiency of that specific module, of course, we do have to apply low irradiance, and I'm at the moment not sure about a specific standardized way of measuring that on the front and the rear side. I think that doesn't exist yet.
Okay, so maybe the person who really asked this question, maybe he can get some more details from you in the chat window. But there is also a tricky question. So, how it would look like the testing when you are putting bifacial modules into bifacial cells into the monofacial module. So is there going to be anything different?
I would expect these modules will be dealt as standard modules in the first stage. Yeah. But it's just an expectation. I would have to ask back to my expert colleagues.
Okay.
Yeah.
So then there is one more question, like rear side power measurement. Is reference cell in sun simulator should be of the same type? Means rear side of the cell can also be front side cell. So this is regarding the reference cell for the front and rear side when you probably have illuminating on the both sides.
I would imagine to have the same single side reference cells to measure the rear side illumination in a bifacial solar simulator. Yeah.
Okay.
Does that answer the question?
Yeah, I think so. Yes. Okay, so thank you very much for this very valuable insight. And please stay till the end of the event. And there are also a lot of questions in the chat room, but unfortunately we cannot cover it because of the time. So please answer, whenever you feel like.
I'll try to find my way. Thank you very much
Thank
for your interest.
Thank you.